The last part of page 5 is talking about reactivity. So reactivity refers to how likely an atom is to have a reaction. What that means is how likely an atom is to gain or lose electrons. So it's all about the electrons, specifically our valence electrons. So it's how easily electrons can be gained or how easily electrons can be lost. So gained from another atom or lost to another atom. If something is a noble gas that already has a full valence shell, it is already stable, it is non-reactive. It's not trying to gain or lose electrons. So our noble gases are referred to as inert. I'm going to write that over on the side. So noble gases are inert, which means non-reactive, because they're not trying to gain or lose electrons. It's gaining and losing electrons that makes things reactive. With that in mind, if we talk about which group is the most reactive, we have two most reactive groups. One is the most reactive metal group, and the other is the most reactive non-metal group. So if I'm looking at my periodic table, the groups that need to move, which means gain or lose, the least number of electrons are going to be this group right here. I'm going to not include hydrogen. Or this group right here. Because remember that this group needs to lose one valence electron to be stable, and this group needs to gain one valence electron to be stable. So in both of those cases, all you're doing is moving one electron one way or the other. Because of that, those are each of our most reactive groups. This is my most reactive metal group because they're metals, and this is my most reactive non-metal group. What you should have gotten from the pages 3 and 4 notes were that this group is called your alkali metal group, and this is called your halogen group. If you are not familiar with that yet, maybe you haven't taken the notes yet, make sure that you go back and get those. So your most reactive metal group is called the alkali metal group. It's group 1 on your periodic table. It is the most reactive because they only need to lose one valence electron to become stable. And similarly, the most reactive non-metal group is called the halogen group. And they are the most reactive because they only need to gain one electron. But in both cases, we are moving just one electron. So I'm going to put on here that it's relatively easy. Relatively easy to move one electron. And then I'll zoom that out so that you guys can see it. Just as a heads up, I will sometimes refer to the alkali metal group, your group 1. We'll call it just the alkali group, just so that you're not using the fact that you know that it's alkali metals to give you the answer. So I'm talking about like if I give it to you on a test or a quiz as like a multiple choice option, make sure that you can recognize that word alkali. So that means group 1 or halogen group, that's group 17, the one right in front of your noble gases. And then finally, our recap of the 3 trends that we just went over. Our largest atomic radius, who's our key player? What element are you trying to be close to for atomic radius? You remember? We called him something cute. FR, Big Frank. Good. Highest ionization energy. Ionization energy is who is hardest to steal from. Note that this was not the order we learned them in. Still the same element, but not the order of the trends. Helium, good. And highest electronegativity. Fluorine. So, helium does not have the highest electronegativity because the noble gases don't want electrons. They're not trying to hog them. They're not trying to take them from anybody else. So, these trends look similar. They're both up and to the right. That's up and to the right. But helium is not included in the electronegativity trend.